Okay, folks, another day, another portfolio test. This one answers a question that many math students have had over time, and that was, what am I going to do with this? How does math apply to real life? Well, statistics is one of the most commonly widely used areas of math, basically being able to predict, estimate, forecast. We want to know what's going on in the future. We want a tool to be able to understand what's happening in the world around us. Statistics. Specifically, what we're talking about here is a statistical process called regression analysis. Your TI-84 calculator will do this for you. I'll show you that in a moment. Basically, what regression is you have a set of data points in a scatter plot, like you see at the bottom of the slide here. And what regression analysis does is create a function, a linear function like you see here, a straight line, a quadratic function, which you'll see in a moment. But any type of function, exponential, logarithmic, quartic, quintic, any function family. And this function best predicts these data points. These data points do kind of look like they make a line, right? So a linear function does predict the data that's on the bottom there the best. And we can use that function as an equation to see what's going to happen 5 hours in the future, 5 years in the future, etc. Okay, so the most important thing to understand is that the result of regression analysis is a function. It's an equation, okay? So we'll see that in a second. All right, so here's my situation. I am a restaurant owner. I want to track and analyze how much my customers are tipping, right? So I'm recording this data, these meals 1 through 6. I have a bill of $34 here. The tip amount was 5 and so forth. So you want to write an equation for the linear regression model and the quadratic regression model based on this data. Okay, let's go to our calculator. So I've previously stored as a list this data from this particular data set, and I'm just going to jump to that first. So I'm going to go to Edit, List, and then Edit, or Stat, sorry. Let me do that one more time, just so it's clear. I'm going to press the Stat button, and then Edit is editing the list or the data set. And if I press number 1 or Enter, then I get my data set. This is what you saw in the last slide. Okay, now the calculator is going to perform this regression analysis for us, generate an equation from this data. How do you do that? If you press same Stat button, right arrow over to Calculate, go down to Linear Regression first, and then go down to Calculate, press Enter. This is our regression analysis. So we'll see this in the slide in the moment, but this gives us a linear equation in the form y equals ax plus b. It's got something called my coefficient of determination, which follows, right? That's my linear regression. I can do the same thing with a quadratic regression analysis. Stat, right arrow to calculate, go down to 5 or press 5, press Enter, go down to calculate, and this is my quadratic equation, which matches it. Here's my a value, my b value, my c value, and a quadratic equation in the form y equals ax squared plus bx plus c. Here's my coefficient of determination. So you're doing all this functionality on your calculator. Now something to remember that, and I'll have a reference for this, no problem, is that I've turned on a feature which allowed me to see my coefficient of determination. So I'm just going to show that real quick in this video. If I go to Mode and then scroll down in this menu to Next, keep scrolling down, I want to make sure my stat diagnostics is on. I previously turned it on, but that's what allows me to see that r squared, capital R squared, and lowercase r squared values. Okay. So let's go back to the slide here. This is my linear. This is my quadratic. They're just screen captures of what I got there. Linear, I say, write the equations for a linear regression model and quadratic regression model based on the data above, round the coefficients and constants in each equation to the nearest thousandth. So it spits out a lot of decimal places here, right? This is very common. You have to round to the nearest thousandth, which is 3 decimal places. Here's what that looks like for the linear equation. 0.146x, that's a in here. and then minus 0.820 really, but that's also rounded to the nearest thousandth. So I just want to point out that this A value is this A in here, and that is this in here. And then this B value is this in the equation. It's the y-intercept. It's the B value in my screen here, and that is this number in here. Okay, same thing with my quadratic equation. This is my quadratic equation. Rounding everything to the nearest thousandths place, but once again identifying per color. My A value is this decimal in here, rounded to the nearest thousandth is this, 0.002. I left off the 0 point in the end so I could make it a little bit smaller, but they mean the same thing. And then my B value here, which is the B, the coefficient to the linear term in the quadratic function. That's this number here. And lastly, my C value, because the quadratic also has a constant here, that is this C value in here. So you might need some practice writing this, but that's all you need. Just a couple of questions to kind of get you in tune with it. We're going to do that in a moment. Okay. So next thing is that I am given my r squared in here, and also capital R squared for quadratic, right? Lowercase r squared for linear, capital R squared for quadratic, in my output, right? Those values, lowercase r squared and capital R squared, are called the coefficient of determination. That coefficient of determination, it's always going to be a value from 0 to 1. And what it does, and I'm going to highlight this here, I bolded it so we could definitely see this. The closer the coefficient of determination is to 1, the better the model's equation is for the data. So you're choosing between these two models, and you're like, which one am I going to use? Oh, okay. Well, let's see. My quadratic is 0.78 to 55, right? And my linear is 0.74, right? So which one is closer to 1? 0.78 or 0.74? Well, clearly it's the quadratic equation, right? So for that reason, I'm just going to type in my answer here, right? The quadratic model fits the data better. Okay, so that's my answer. I've chosen this data in here because this capital R squared is greater than lowercase r squared. Okay, so that finishes up our topic for today. We're going to practice this a little bit. We're going to go into the application of this model as well, like in terms of a contextual problem, meaning like this data was about a restaurant and the tip versus the bill. And then we're also going to look at the functions graphs as well too for this portfolio test in the next class. Okay, we'll see you then.